back, does your homework. This is homework number 3, question number 5. The question states, when the shuttle bus comes to a sudden stop to avoid hitting a dog, it decelerates uniformly at 3.5 meters per second squared as it slows from 9.5 meters per second to 0 meters per second. Find the time interval of acceleration for the bus. So what's happening here? I've got a bus that starts out, let's try to draw a bus, there's my bus, that starts out at it slows from 9.5 meters per second to 0 meters per second. So it starts out at 9.5 meters per second, and then at some time later, that same bus has come to a stop and is now going 0 meters per second. And the amount of time is what we're looking for, but it decelerates uniformly at 3.5 meters per second squared. Now, if it's going from 9.5 down to 0, we would consider that a negative acceleration, because the acceleration must be happening in this direction. There's something acting on the bus that makes it slow down. So that's going to be the brakes acting backwards on the bus to make it go from 9.5 down to 0 meters per second. But my initial velocity for that bus, my v0, is going to be 9.5 meters per second. My final velocity, v, is going to be 0 meters per second. I don't know my time. That's what I'm looking for. So time is question mark. But here it tells me that it decelerates uniformly at 3.5 meters per second. Now I know that going from 9.5 to 0, that's a negative acceleration. If I'm at 9.5 and I positively accelerate, if my acceleration is positive, then this number 9.5 is going to go up to 10, 15, 20, and so on. But instead it goes from 9.5 down to 0. So I have to recognize here that my acceleration is going to be negative 3.5 meters per second squared. So now I've got a velocity initial, a final velocity, a time, and an acceleration. The way these 4 variables are related is that my average acceleration is going to be my change in velocity divided by the amount of time that passes, or it's going to be my final velocity minus my initial velocity divided by time. Now if I want to solve for time, what I can do is, let me just set this equal to a. If I multiply both sides by time and then divide both sides by acceleration, then I'll have time all by itself. So here I'm going to multiply by time, so I'm going to get AT over here, and I'm going to multiply this whole thing by time over here. Let me take my eraser and get rid of a little bit of this. So if I multiply by time over here, then you can see that time goes away. So I'm going to get AT equals V minus V0. And now to get time all by itself, I'm going to divide by A. So I'm going to divide by A. So now my acceleration goes away over here. So acceleration, acceleration. So now I know my time. So let me write that out. I'm going to rearrange this, and I'm going to say that my time is equal to my initial velocity minus my final velocity divided by my acceleration. So now let me plug in my variables. You'll notice I rearranged the equation before plugging in any variables. It's also okay to use your initial equation, plug the numbers in, and rearrange later, but sometimes this is going to help out a lot to see how relationships work, and it saves you some algebra problems later. So my final velocity here was 0. My initial velocity is 9.5 meters per second. And my acceleration is negative 3.5 meters per second squared. Now wait, what's going on here? I'm going to have a negative up top because 0 minus 9.5 is just going to be negative 9.5. I'm going to have a negative on the bottom, negative 3.5. Oh hey, that's going to work out really well because my negative and my negative will cancel out, giving me some positive amount of time, which is always a good thing to have time be positive. So my time is going to equal 9.5 divided by 3.5. Now what about my units here? So that's going to give me some number. So negative 9.5 divided by negative 3.5 is the same as 9.5 over some number. What about my units? I've got meters per second divided by meters per second squared. So that's going to be meters per second over meters per second squared. Well, when you divide by a fraction, it's the same thing as multiplying by the inverse of the fraction. So this is going to be the same as meters per second times seconds squared per meter. Look at how this works out. So now what can I cancel out? Well, I've got meters on the bottom and meters on the top, so that's going to go away. I've got seconds squared on the top divided by seconds on the bottom. Well, this seconds is going to get rid of the squared and leave me with just seconds. Oh, wow, that's really convenient because time sure better be in seconds. So my units work out. When I have meters per second divided by meters per second squared, I wind up with just seconds, so my time is going to be that number of seconds. And there's your answer.